Hello everyone, this is Steve. Thanks for watching. This video is going to be an example of using completing the square to find the zeros of a quadratic. So we are given a problem that looks like this. Solve x squared minus 6x minus 55 equals 0. Now with this type of quadratic, it's very, very tempting for some people who are really good at factoring to just ignore the completing the square instructions and say, I can just factor this and find the answer. The reason we start with this example is because I want you to see that completing the square gives you the same answer as factoring when factoring is possible. So it is very, very tempting to go ahead and just say, well, I know that 5 times 11 is 55, so I'm just going to use a negative 11 and a positive 5, and then doing a little bit of work in my head, I've got the answer and I'm done with the problem. And while that is the correct answer, we're not going to solve this problem that way because we want to practice completing the square. So let's go ahead and get rid of this, and we'll solve this by completing the square. First step to completing the square is to verify that you have a coefficient of 1 in front of your x squared, which we do. So the second step is to move the constant over the other side using legal mathematical operations. So we will add 55 to both sides. Then you examine the number that appears in front of the x, not the x squared, the number in front of the x. And you write it down, including its sign. So you see here we have negative 6, so we write that off to the side. You take negative 6 and you cut it in half or divide it by 2, and you get a negative 3, and then you square that number and you get a 9. And that 9 is added to both sides of the equation. X squared minus 6x plus 9 equals 55 plus 9 is 64. The whole point of doing that is to turn the left side of the equation, where you have the x's, into a perfect square trinomial. So now it can be factored where both factors are identical to each other. So this side on the left should be able to be factored like this. Now, if you're awesome at factoring, you would know that a minus 3 goes in here. If you are not so awesome at factoring, you can use this little trick, and that is when you took this number here and then you cut it in half, that's the number that's going to appear next to the x in the parentheses. So this negative 3 over here and this negative 3 right here are not a coincidence. It will actually always work out that way. So that's a good trick. It takes away the guesswork. Now that we have completed the square, because we have a perfect square on the left side, we take the square root of both sides. So we put in a big radical over here. And this side doesn't just pick up a square root, it always picks up a plus or minus. We're going to get two answers here. Now, on the left side of the equation, the x minus 3 squared and the square root cancel each other out to give us x minus 3. And over here on the right side, we know the square root of 64 is 8, so we get plus or minus 8. We're trying to solve for x, everyone. That's the end game. So we add 3 to both sides. We get 3 plus or minus 8, which means 3 plus 8 is 11, and 3 minus 8 is negative 5. Those are the two zeros of this quadratic, which are actually the same thing numbers we got when we factored, but this time we did it by completing the square. And completing the square is important because you want to always be able to factor. So we need to learn this technique so we can use it on more complicated equations. Thank you for watching.